Good morning and welcome to the solution videos to the 2022 MetaHacker Cup, round 2. I'm David Harmeyer and this is the solution to problem B, balance sheet. This is of course a pun on an actual balance sheet, which is like a thing that companies use to write down the amount of money they get and spend, and then you balance it out, or bank balance rather than balance as in something is perfectly balanced physically. So, all right, let's jump into the problem. So in this problem, you have a company called Metal Platforms and they sell sheet metal. And you want to sell this sheet metal between traders in order to make money. So the way it works is you have some traders, and each trader will want to buy a piece of sheet metal on one day and sell it on a later day. So for instance, this trader right here, he wants to buy it on day 1 and then sell it on day 3, and he's going to buy it for $15 and sell it for $5. These prices are already fixed, and you're given all this information ahead of time. So now the question is, we want to have a single sheet of sheet metal and sell it between people and make as much money as possible. So the question is, for the best K paths, what is the sum of money that Meta can make? Let's look at some example here. So in this case, we have this piece of sheet metal. The person would buy it for $15 and then they're going to sell it later on. Then when they sell it, we can give it to this person here who will buy it for $15. This person sells it for $5 and then we buy it for $15. So in this case, Meta gets a profit, or Metal Platforms, gets a profit of $10. And then here, this person is going to sell it for $0 and someone else will buy it for $20. So this is a profit of $20. And then here we have two different choices. We can sell it to this person or this person, but both people are going to buy it for $20 and sell it later on. So we don't care very much. There's no profit in it for us there. So the most profit we can make here is 30, and there are two different paths that will give us this $30 profit. We can take this person, and this person, or this person, this person, this person. We also have another path that would give us a profit of 5 here plus 10 here. So that would be what, 15? And that would give us profit as well, although it wouldn't be quite as much. So the question is, how do we find the sum of the profitability values, of the K most profitable paths? Well, it's a bit tricky, but we can do a DP. So the important thing to recognize here is that this graph is ordered. It only processes things that happen later on in time. So the best answer for a particular person only depends on what happens after that person in time. Let's look at some example, for instance. So let's say we want to know if this person ends up in part of a path. What is the biggest profit value the path can have? And for the best K of them, what's the biggest profitability that those K can have? So we're going to look at all of the things this person can reach. In particular, we're going to look at this person here and this person here. And then for each of them, we want to look at the best K. And we're going to keep track of, for this person, what is the best K they can reach over all of the possible transitions they might hit. So the final runtime here is going to be n times K. But we have an issue, which is you've got one person here, and they have potentially n things that all start on this day. So you can imagine a graph, I'll draw it in the same format, that looks something like this. We can have a bunch of different people that have edges like this, right? So we can have something like this maybe. And then we can have a bunch of other edges all over here. And if we do this naively, we're going to run into the issue of, okay, well, this might go to n different things, right? How do we know which one is best? So what we'll do to get rid of this n squared part is we'll look at, for each day, we'll process things from most expensive to least expensive. And then we can store what are the K best transitions across all of the different people you can go to. So this will bring our runtime down from n squared to like K log n. In particular, the way that we store the best ones is every time we have a person, we'll look at the K things they can reach, the best K things they can reach, and that'll already be processed because we'll process this DP from right to left. So we know the best K answers for each of these n nodes. And then when we hit the start node, we'll look at the corresponding n nodes, consider each of those K answers, and then we'll put the best ones into a priority queue. And we'll make sure our priority queue stays size K. So when we do that, we'll be able to figure out the answer when we do a query, because we only have K different things to look through, and we can store these in a priority queue. All right, so that's the solution idea to problem B. I hope you enjoyed, and I'll see you in the next one. Goodbye.